Howdy one, my name is Phoenix. Welcome back to another live stream. Today is March 29th, 2029. And today this marks a very new streaming strategy. Usually I'd stream on Twitch during the weekend, not weekends, during the breaks and during the winter breaks. Not winter breaks, but breaks in general when I'm off on campus. But today is different. Today I'm be doing my very first studying stream, which is a live stream, which is a live stream where where I do studying instead of playing video games. So I'm just gonna be checking to see if everything's working good and making sure everything is working fine. Everything's going good. That's wonderful. So yeah, I'm just sorry if the my OBS. I'm looking at another monitor over here, so it looks a little bit compressed. I notice if you see my other live streams, my footage seems a little compressed. Like it's not compressed, but like it's a little squished together. Yeah, that's an issue I did with my OBS. I take 100% I'll take 100% responsibility of that. Just gonna make sure. Let's make sure this is working well. Okay, it's working perfectly. So yeah, today I'll be. Hold on, let me share my screen with y'all. Hmm. Gotta make sure everything's working perfectly. Hmm. Some issues like my screen's not showing the. Hold on. There's an issue. Something's wrong. Hold on. Let me adjust this back. Hmm. Sorry if you hear the audio in the back. So I don't understand what's the issue. Like it's not showing. The screen is not. My screen's not sharing with. No. We got an issue. Sorry, everyone. Okay, we're back. Oh boy. This one in my eye. See, I was supposed to be going. Supposed to connect like my screen to OBS, but something's the issue. Let's keep it like this. Something's wrong. And please excuse how my webcam's a little dark. Oh, there it is. Sorry about that. Wait, what? There it is. Yeah, we got the issue. Sorry, everyone. So yeah, this is my gotta reset start the clock because I haven't. Yeah, so today I'll be. Hold on. Yeah, today this is my very first studying stream where I'll be studying for my classes instead of playing video games because I want to. Yeah, this is something I've been thinking about doing for a while that I've never actually like. This is something I've been planning on doing for a while. One that I never got the chance to do until now. Like I've combined studying, which is something I need to do for this to pass my classes for the semester, and also playing and also streaming.
Work today is broken.
No, I was doing proof by cases, so I just got to rearrange some stuff in order to like.
What we're trying
Let's be straight. This
to think through is all of the different ways in which a situation could happen.
by cases.
For instance,
I'm just gonna write this stuff down. I know today may be a little bit of a boring live stream. And yes, there's not much brightness. I came downstairs. I'm actually in my prayer room, which is where I used to do a little bit of my live streams here, but like it's not really the best. It doesn't really give me like the best light. I mean, I have a light up over there, but I should probably bring down my lamp. I'll be right back. Here I am. See how this is worked. See how this is going. Bring it closer. Ooh. Gotta adjust OBS. Sorry if it's getting a bit too bright. This is my very first time streaming on YouTube. Hold on, I gotta yeah. Very first time streaming on YouTube. I usually do it on Twitch, but today, hey, we try something new every day. This looks good, yeah. I think this looks good, okay. Perfect.
I'm going to prove if n is an integer.
Just writing this down. If approved by cases, because I have an exam on Thursday, next Thursday that I want to study for, because let's be honest, I am not doing too good at discrete mathematics. Yeah, and make sure the audio is doing good. Have to do that for every live stream. Let's see how the stream is doing as well. 8 views. 8 views, dang, really? Proof by cases? Because on OBS it's telling me that I have 8 viewers, and I want to, I guess, so I'll take it with a grain of salt from this. You must cover all. Also, I'd like to mention today is probably the last day of Ramadan. Eid al-Fitr is tomorrow. So, and if y'all know, I'm Muslim, and tomorrow is going to be a big day for me, as it's going to be Eid al-Fitr for all Muslims in the world tomorrow, March 30th. Sorry, just checking. So, example, prove if n is an integer, n is less than or equal to n squared.
Then n is less than or equal to n squared. So here's an implication: if P, then Q. Now, hopefully at this point in your mathematics study, you have determined that negative values sometimes react differently in a function than positive values, and 0 often acts differently than anything else. So that is what I chose to use for my cases. I'm going to take a look at what happens when I have a negative value, which I'm saying n is less than or equal to -1. So let's think about a number line here for a minute. -2, -1, 0, 1, 2, and Notice that I'm using just integers. So if I say n is less than or equal to -1, that gives me -1 and any integer to the left of
I'm
that
writing
on
this
my number
down
line.
on my paper.
Case 2 says n is equal to 0, again because 0 often reacts differently than other things. That takes care of 0. And n is greater than or equal to 1 starts at 1 and gives me anything to the right of that. And so you might be thinking, well, that's great, but look, you've got some spaces here, so you're being sloppy. Now, if this were any real number, not any integer, then those spaces would be a real problem. But because I'm dealing with integers only, then this is an exhaustive proof because I'm using all of the integers less than or equal to -1. The next integer is 0, which I've covered. The next integer is 1, and then I have everything greater than 1. And so this is exhaustive, meaning that I have covered everything. Now, if you get uncomfortable with those spaces, instead just say n is less than 0 and n is greater than 0, and you're going to get the same result. Now that we know our three cases, let's go about making this proof happen. Case 1 says n is less than or equal to -1. Keep in
paper
mind
here.
what I'm looking for each time.
I'm gonna write this down. I don't want to get left behind. Let me check to see how the live's doing. 9 views, is that true? Like, am I really getting 9 viewers? Push my lamp back. Is it really true I'm getting 9 viewers? Like, if it's true, great, but like, OBS could be saying some weird stuff right now, and I gotta take it with a grain of salt. Case 1 should be there.
Is to show that this relationship is true, that n is less than or equal to n squared. So what happens if I have a negative value? If I have a negative value and I square it, n squared is always going to be positive. It's always going to be positive because a negative times a negative is a positive. So therefore, it follows n is less than or equal to n squared because n squared is positive and n is clearly negative. Now, notice I didn't write all of those words. I would write all of those words if I were doing this proof for an assignment or a test. Case 2 says n equals 0, and whenever you have an equal, you just do direct substitution. 0 is less than or equal to 0 squared, and 0 squared is, of course, 0. 0 is, in fact, less than or equal to 0. Therefore, it follows that n is less than or equal to n squared for case 2. For case 3, n is greater than or equal to 1. So if n is greater than or equal to 1, and I multiply the left side by n, and I multiply the right side by n, I end up with n squared is greater than or equal to n. So it follows that n is less than or equal to n squared. So how would I wrap this up? Since n is less than or equal to n squared for all cases.
I'll pause the video so I can catch up.
Or for all values in our domain. we can conclude if n is an integer, then n is less than or equal.
Whoops, I made a mistake. Should really use a pencil for this instead of a pen. I just wanted to use a pen because all my pencils were starting to get like used up. If that makes sense, like, and also I don't have a sharpener, so I really have to walk a fine line and use the pen today.
To n squared. Let's take a look at another proof.
Sorry if this live stream is a bit boring compared to my other live streams. I just decided to do a little bit studying while I go on live on YouTube. Go on YouTube Live. Check and see everything's going good.
This is a proof of an implication. If P, then Q.
Hold on. If P.
And again, even though there's no then, that's okay. And what I'm looking at now is how do I prove this? Well, in our last proof by cases, we were concerned about the sign of the value, whether I'm plugging in a positive, a negative, or a zero. Here, instead, I'm worried about the parity, whether something is even or odd. So I'm going to have three cases here. I'm going to say case one is n is even. Case two, n is zero. And again, I'm using zero.
Case one, n is even.
Because zero is not considered even or odd. And then case three is n is odd. Because based on what I'm trying to prove, that something is even, I know that what I plug into it may have some effect on the outcome. So if I start with case one, I'm saying n is even. So therefore, n is equal to 2k for some k that is an integer. So then I'm going to take n squared plus 3n plus 2, and just continue to do the math here. So if I square this, I get 4k squared plus 6k plus 2. And then if I take a 2 out of everything, I get 2k squared plus 3k.
Hold on. Sorry, I keep pausing it so much. I just try to like understand.
Plus 1. And remember the way that we did this before is quite often we'd say, well, that
I'm putting my other papers aside.
that's equal to 2r, where r is equal to all of that stuff. 2k squared plus 3k plus 1. So why does that matter? Because what I've just shown is that for case 1, if n is an integer, then n squared plus 3n plus 2 is even. So 1 out of 3. Case 2, again, this is just an equal, so I'm just going to plug it in. 0 squared plus 3 times 0 plus 2, which is equal to 0 plus 0 plus 2, which is equal to 2, and 2, last I checked, even. Case 3, n is odd. So if n is odd, then I'm going to say n is equal to 2m plus 1 for some m that is an integer. And I'm going to do the same thing I did before for case 1. And I'm going to say n squared, so n is now 2m plus 1 squared, plus 3 times 2m plus 1 plus 2. Remember that I'm foiling this. I'm not just squaring each of the terms. So that gives me 4m squared plus 4m plus 1. And then I'm distributing the 3, so that's 6m plus 3, and then I still have the plus 2. And then I'm simplifying to get 4m squared plus 10m plus 6.
Oh, sorry if I keep pausing it. I'm just trying to catch up.
And then I can take a 2 out of everything to get 2m squared plus 5m plus 3. And again, I can say all of this stuff is equal to, say, L,
Why L?
where L is equal to everything I had in there, 2m squared plus 5m plus 3, which is even. And again, then I just summarize. Therefore, n squared plus 3n plus 2 is even if n is an integer. Or, of course, I could say if n is an integer, then n squared plus 3n plus 2 is even. You get the idea? It's the same thing.
Are you struggling in your calculus class? Do you have a hard time understanding your instructor?
Yes and yes.
Do you wish there was a simpler way? I get it. It's frustrating. You go to class expecting answers only to walk away with more questions. And because your teacher and your textbooks skip those important in-between steps, you lose valuable study time, Googling homework problems, desperately searching.
Did they know I was coming
I'm going
here?
to go through just one more proof with you, but this one's kind of a doozy, so I'm going to spend quite a bit of time on it.
Also, sorry, I have a textbook right here to show, just to like navigate me through here. Oof, I got a lot to study for. I don't understand any of this nonsense. Views. Let's see how. Oh, sorry for hitting my mic. Checking on the live stream, see how it's doing. Views. Let's see how. Oh, sorry for hitting my mic. Y'all know. Probably should not show.
The
Doesn't
reason
matter.
this one's a little bit different is it still is an implication, which we're used to.
Sorry if y'all can hear my laptop fan. It sounds like a jet engine right now.
But if you'll notice, I have quite a bit going on here in the first part of my implication, and then my second part just says both x and y are even. So I want to talk to you about how this would look using propositional logic. If I let P represent x times y is even, and if I let Q represent x plus y is even, and then I let R represent both x and y are even. This is the way I'm choosing to do it. Now, as we know, there's lots of different ways to represent things using propositional logic correctly. This is the way that I'm going to do it. So based on the way
Let's move
that
my
I
mic
have assigned
here,
my
like back there.
propositions, I can rewrite this statement as if P and Q, then R. If x times y is even and x plus y is even, then both x and y are even. And
It
again,
sounds
I
fair.
totally skipped this our integers part, but again, I would just say for the domain of integers. Now, the reason that I wrote this using propositional logic is because though I'm going to use a proof by cases, I'm going to also use a proof by contraposition. So if you'll recall, a proof by contraposition says if I'm showing if P then Q, a proof by contraposition would assume not Q, and you would then prove not P. The reason I bring this up is because if I do that here, then I'm saying if not R, then not P and Q. And hopefully you recall De Morgan's law that says not P and Q would be not P or not Q. So what I'm going to do is I'm going to assume not R and then show that either not P or not Q is true. Now, one more thing that's going to make this a little bit more complicated, because obviously this is a proof by cases. Let's think about what my cases are. So I could have that x is odd and y is odd, or x is odd and y is even, or x is even and y is odd, or x is even and y is even. So you might say, okay, cool. We've got 4 cases. Let's get started. But that's not quite the case. I am assuming not R. R says both x and y are even, so I'm assuming that's not the case. I'm going to change colors there. I'm going to assume case 4 is not a possibility.
Whoops,
So
made a
that
little
leaves
bit
me
of a
3
curve.
cases. Now, I could
Hold on, I was drawing this very thing on my paper, but I made a mistake, so I have to like just basically scratch it off. Not scratch it off, but like write it off. I really should have used a pencil for this kind of nonsense.
could go ahead and do these 3 cases, and that's just fine. But I want to introduce to you a concept that's called without loss of generality, because you're going to see this throughout your studies, and I don't have a whole video on without loss of generality. So essentially what this means is if you would take a closer look at case 2 and case 3, and I'm looking at what's going to happen with P and Q. Case 2 says X is odd, so let's just make up an odd number. And let's say I'm multiplying that by an even, because again, I'm looking at case 2. So if I multiplied these two, I would get an even number, and if I added these two, I would get an odd number. Now let's take a look at case 3. X is even, Y is odd. So let's say I take 2 times 3, and I get an even, and again 2 plus 3, and I get an odd. So what I'm telling you is based on what case 2 and case 3 are, and based on the propositions that they are affecting, case 2 and case 3 are exactly the same. So when we use something called without loss of generality, we're saying, I'm going to assume something is true and it's not going to affect the outcome because there's, for instance, more than one case that has the same outcome. So without loss of generality, I will assume, I'm not going to use that arrow because then you'll think it's an implication. Without loss of generality,
anyway.
I will assume that X is odd. Again, why? Because I'm just going to show case 1 and case 2, and I'm not going to show case 3 because case 3 is going to give me whatever happens with case 2. So now that we've done all of the setup, let's actually do this proof. So I've made the assumption without loss of generality that X is odd. Therefore, X could be written as 2m plus 1 for some m that is an integer.
A proof. If x and y are integers and both x and x times y and x plus y are even, then both x and y are even. Assume without loss of generality that x is odd. So x equals 2m plus 1, and for some 2m is, what does that z sign mean again? Crap. It'd be like an integer, m belongs to an integer. Is one, y is odd. Comma y equals 2n plus 1. Case 2, y is even. Y equals n. I'll write this stuff down. So looks like my folks are home. We'll still continue to stream.
My
All right, we'll check the time. How long I've been studying for?
2 cases
34
are that
minutes.
y is odd or that y is even. Now, if you'll recall what I'm trying to show, so before I actually get started on it, I'm trying to show either not this or not this, again, by De Morgan's law, which we went through just a few moments ago. So let's see what happens. Case 1, I'm going to find x times y, and I'm going to find x plus y, and I'm going to see what happens. And remember, we're saying these are even, so if I'm saying not that, I'm really just looking for one of those to be odd. So I'm looking for one of these guys to be odd. So x times y would be 2m plus 1 times, we're letting y be 2n plus 1 because it's also odd. And if I FOIL, I get 4mn plus 2m plus 2n plus 1. If I take a 2 out of the first 3 terms, I get 2mn plus m plus n plus 1. And again, I could just rewrite that as 2r plus 1, where r represents 2mn plus m plus n. And therefore, this is odd because it is written in the format of an odd number. I'm going to move over this x plus y because obviously I'm going to run out of room if I don't. So x plus y, and I could stop right there for case 1 because I've already shown that one of them is odd, but let's go ahead and just see what happens. 2m plus 1 plus 2n plus.
I'll move my 2x plus y, my x plus y. I mean.
Plus 1 gives me 2m plus 2n plus 2, which gives me 2 times m plus n plus 1. 2 times something, this is an even. But again, I'm not concerned by that because I just need one or the other to be odd. So far so good. Case 2, again, I'm still looking at x times y and x plus y, but now y is even, so y is represented by 2n. So x times y would be 2m plus 1 times 2n, which gives me 4mn plus 2n. This clearly is going to give me an even value. But again, I'm not concerned unless this guy is also even. So now let's try this guy and see what happens. X plus y would be 2m plus 1 plus 2n. I could rewrite that as 2 times the quantity of m plus n plus 1. And again, I could rewrite that in another way, but this is clearly an odd number. And I don't have a ton of room for the conclusion, so I'm just going to say the conclusion aloud that if x and y are integers and both x times y and x plus y are even, then both x and y are even. And again, this was a proof by contradiction and contraposition. Now that we have learned quite a few different methods of proof, we are going to take a look at some types of proof, which are proofs of existence and uniqueness.
That is great, lady. Thank you so much for helping me. All I gotta do is just search up sets. This is my textbook that I have to use in my class. It's here. Best, so we're moving on to sets. A set is an unordered collection of distinct objects called elements. Sorry, I got something on my lips. Or members. Oh, screwed it up. Cross out this line. This is why it's better to write with a pencil, because pencil's like, if you make a mistake on your paper, you can just erase it with pencil. I can't do this here with It's making it worse. My goodness. We write A and what does this sign mean again? I'll search it up. Put on ChatGPT, but Oh, great. Belongs to, oh, I get it. Use A belongs to A to detonate that A is an element of the set A. The notion lowercase a doesn't belong to A detonates that A is not an element of the set, not an element of the set A. So it literally just told me what it meant. Next time I'll remind myself to not use pens while studying, because I can't erase my mistakes.
This video is an introduction to sets, and that includes both vocabulary and notation. Before we begin working with sets, it's important to understand what a set is. So a set is simply an unordered collection of objects. So for instance, if I wanted to tell you that I have 3 brothers, I could say the set of people who are my
I need to get more paper. Because I'm not writing this down on my notebook. This is just on a blank piece of, no longer blank piece of paper, but it's just on a piece of paper that's not attached to my notebooks. Because my notebook, it's starting to run out of pages. I have a few pages left, and I intend to use this for when I go back to campus on Tuesday for discrete mathematics class. Let me check outside. Dad's song. I'm gonna have to open a door for my dad because he's here.
My brothers include Eric, Adam, Kevin, in no particular order. So I didn't write them youngest to oldest, oldest to youngest, favorite to least favorite, etc. Just unordered. An element is simply an object in the set. So the elements of set B are Eric, Adam, Kevin. And notice they're just separated with a comma. And then, of course, we have the notation here. So this means is an element in the set or is contained within the set. So I could say Adam belongs to set B. Larry does not belong to set B because I don't have a brother named Larry. So it means it's contained in or is an element.
Oh, are you okay? Are you okay? It takes way out quite a bit. Sorry, when I'm back. Everything's fine. My dad came home. He was just calling the insurance company because because his rental car got hit at the back. I probably shouldn't tell him. Probably should keep this to myself. His car got hit at the back. He's fine. He's not hurt, which is a good thing. But he's just calling the insurance company right now just to say just to talk about the car because the car at the back of the car, yikes! It looks kind of wrecked. The front works fine, but the back, whoa, whoa, whoa. Anyways, back.
Element in, and of course not contained or not an element in.
I should have kept that to myself. Not everything.
There are several sets that you should know.
Some more paper. I want to see if we hit our 1 hour mark. No, we're still like 52 minutes into studying. I'm just writing this stuff down on my paper.
And it's very possible that you already know all of these, but I'm going to go through them anyway just to be safe. So the first set you should know is the set of natural numbers. The set of natural numbers are just the counting numbers. So if I wanted to start listing them, it would be 1, 2, 123 onto infinity. W represents whole numbers, and whole numbers are 0 and
So I just gotta write this down.
the natural numbers, which means same set but starting with 0 instead. Then we have Z, which represents the integers.
Yeah, I remember this. This was like in pre-calculus and college algebra. I remember like natural whole numbers, integers, those phrases.
And the integers are just the positive and negative whole numbers. And of course, there is no negative 0, but we get the idea that it would be on to negative infinity, -2, -1, 0, 1, 2, on to positive infinity. Then we have the rational numbers, which you would think would be an R, but obviously we have saved the R for something else. Q represents rational numbers because a rational number is a quotient of the two terms A and B, where A and B are both integers. B is not 0 because, of course, we cannot divide by 0, and A over B is in lowest terms. Then we have R, which represents our real numbers, and the real numbers is everything above it. So all the natural, all the whole, all the integers, all the rational, those are all real numbers. So anything that is not imaginary is real. And that brings us to C, which represents our complex numbers. And complex numbers are numbers written in the form A plus BI, where A actually is a real number. It's the real component of a complex number. But as you can see, BI, that I would represent the imaginary portion of that number. So that's all the sets you should know. One more thing I do want to point out. Sometimes you're going to see something like Z with a plus or Z with a minus, and that would just represent the positive integers, or if you're negative, it would be the negative integers. Now let's talk about different types of sets. Now let's talk about different types of set notation. So there's roster notation that is very straightforward. Roster notation, just like the roster of a sports team is simply listing the elements in the set. So you can see set S, I have said, is 1, 2, 3, 4, and 5. So roster notation would just be listing those. Roster notation needs to be used with discrete sets. And what do I mean by discrete sets? Well, hopefully we know, since here we are in discrete math, studying discrete objects. Discrete sets include things that are countable. They are not continuous. So let me give you an example of something that would be not discrete. Would be 0 is less than or equal to x is less than or equal to 1. If I'm looking at all of the values between 0 and 1, there are quite a few. There are actually infinite number of values between 0 and 1, because I could say 0.1, 0.2, 0.3.
I'm gonna pause the video. What is my battery power? My battery 9%. Holy cow! I gotta plug it in fast. I'll be right back. Gotta get my laptop charger. Anyways, I'm back. I have my laptop charger here so I can plug it in and we can continue studying.
3.4, etc. But then I could say 0.11, 0.21, 0.31. You get the idea. I can just keep adding another decimal place, and that gives me a whole nother, bunch of numbers that can be included. So this is a continuous set, and therefore I cannot use roster notation with that set. It has to be a discrete set. Then we have set builder notation. Now, set builder notation can be used for any kind of set. So it could be a continuous set, or it could be a discrete set. So let me show you an example. Still using set S. If I wanted to write set S in another way, I would say set S is all of the elements X such that, so this little line here just means such that, and everything that follows the such that line is describing the elements in the set. So in this case, I could say all of the elements in the set such that X is an element of the natural numbers. Remember, the natural numbers were just the counting numbers. And also that X is less than or equal to 5. Does that describe my set? Well, absolutely it does. It describes my set, but also I could have said all of the elements X such that X is an integer. Well, now integers include the negative and positive values. So here I would have to say that 1 is less than or equal to X is less than or equal to 5. So that's another way to correctly talk about set S in set builder notation. Now let's talk about interval notation. So I'm going to start with set builder notation, and we're going to move to interval notation.
Are you sure everything's going good? Everything's going all right. Let's check the timer to see. We officially crossed the 1 hour mark, which is nice, but we have to keep going.
Notation. We have to have a different set now, because interval notation is what we're going to do with these continuous sets. So we have to use that interval notation, or you can use set builder, but most often interval is the best. It's the clearest, it's the easiest. So let's take a look. Let's say set B is equal to all of the x's such that 0 is less than or equal to x is less than or equal to 1. So it's including
I was just checking on my dad earlier to see how he was doing because he just got into a car accident. I mean, I won't say car accident, like, he got hit. The car he was using got damaged because he got hit by someone. He's fine, he's not hurt. But, like, the guy, I was just checking on the guy to see if he was doing alright, okay? So, if you
all of the values between 0 and 1 inclusive. So 0 is included and 1 is included. So if I'm looking at a number line, where I have 0 and 1, and this might bring you back to middle school days. If I were to graph on a number line all of the values that are included in set B, 0 would be included, 1 would be included, and all of the values between 0 and 1 are also included. Now, if I want to rewrite this in interval notation, I'm going to pay special attention to the endpoints of my interval and whether or not those endpoints are included. So if I'm looking at the endpoints, 0 and 1 are the endpoints. So 0, 1.
Renewal by Anderson presents The Test of Time.
Oh.
Well, it sure
sorry.
seems like a great...
Screw up, ad.
And interval notation, again, is only for continuous sets. So I don't have to say that it's continuous. Interval notation implies it's continuous. Now, 0 is included in this set. So I'm going to use what's called a closed bracket. And 1 is also included in the set. And again, because these both say or equal to. And so that's how I would write that in interval notation. 0, 1 with the brackets on the outside, which are closed brackets. Now, what if instead I said, let's let set M represent all of the x's such that 0 is less than x is less than or equal to 1. So what did I change here? Well, I still have 0 and 1, but now notice 0 is not included because
This would
it's
be an
not
open-
0 is less than or equal to
There'd be a
x,
parentheses.
which means 0 is not included. There we would use an open bracket. Now I've still included the 1, so the 1 would still
Wouldn't
be
it
closed.
just be a parenthesis called a
Or of
parentheses?
course I could have said that 0 is less than x is less than 1, and then I would have open brackets on each side.
Oh, wait, I made a mistake.
Let's
That's my
take a
bad.
look at two special sets. The first is not a term that you're going to hear often, but the concept is important. So the first term or concept is the universal set, and the universal set is essentially the set of all elements under consideration, which essentially just means, what am I studying? So let's say, for instance, I was going to create a Venn diagram, and I'm interested only in the natural numbers. So this box would represent the
Hold on. This is my dad.
universal set of natural numbers. So this box would represent the universal set of natural numbers. So that's how I would denote that. Now, hopefully you've dealt with a Venn diagram before. So anything that goes in this box is a natural number. And let's say then, for instance, I also had a subset, which we're going to talk about more in just a little bit. Let's say the subset is all of the even natural numbers. So where would the number 1 go? Well, number 1 is a natural number. It's a counting number. So it would go within the universal set of natural numbers, but it wouldn't go in here where I'm only containing the even naturals. But I would put the number 2. Number 3 would go out here somewhere. Number 4 would go inside. Number 5 would be out here somewhere. Number 6 would go inside. You get the idea. The box itself is the universal set, and that's the set containing everything under consideration. And then, of course, we'll talk more about subsets in a little bit. Then there's the empty set, and the empty set is simply a set with no elements. And you'll see that denoted sometimes as a 0 with a line through it, like this, or you might see the set brackets, but
Hold on, I think someone's at my door. is small. My sister had came home. She came home from work. Whew, it's kind of toasty around here. Outside is pretty toasty. It is like 75 to 80 degrees. It is spring. Like spring is starting to get warm here in Houston. We gotta like deal with the
with
warm
nothing
weather.
inside, which of course be the empty set. What I do not want to see you do is give me the set brackets around the empty set, because that would imply that this is a set containing one element, and that one element is the empty set. So don't do this. Coming up next, we're going to explore some set relationships.
You can do that. I'll go back to my notebook. Hey, Bob. Can we order something instead? Have you ever tried Dairy Queen?
They don't deliver it here.
Okay, we can get McDonald's tonight. Alva loves that.
Obviously.
Okay, because we got some stuff here. I probably shouldn't have gone live today because, especially on YouTube, because like I don't really want my family members' faces, my family to be on this live stream because they're like pretty private people, and I respect that, and I don't want their faces to be on my live streams and all. So when this video is gonna be uploaded? Well, it's already uploaded on YouTube, but like when this stream is finished, I'll probably have to like private it. I'm sorry. It's not because I don't want to put my family's faces on the internet without their permission. I didn't really think this one through today. I just didn't want to put their personal faces on what? I didn't want to put their faces on YouTube without their permission, or even the internet without their permission. So I'm just trying to keep this. I'm just trying to study today, study and stream. But like, I'll probably have to edit this video out, or probably like list it under private. This is what we got covered. Yes. So all real numbers. What's next? That's ow. Yeah, functions. Also, this also has some sort of practice problem, so for me to do, so I remember these terms, subset and superset, because I take a Python 2 class this semester, and we talk a lot about subsets and supersets, like subsets, and usually when you're coding, supersets are always in the parentheses. Let's see how long it was, like 1 hour and 14 minutes. We've been studying for that long. Yeah, please excuse my conversation with my sister. She asked if we can have something to eat because she's hungry. Probably shouldn't say any of this stuff. Ooh, my dad's pretty pissed upstairs. I mean, I don't blame him. Like, dude just got into an accident. He's fine, but his rental car is like the back of his rental car is busted. This okay. The set A is a subset of the set A is a subset of B, and B is a superset of A. If and only if every element of A is also an element of B, we use the notation A is. I keep forgetting what this means. Let's look back. Belongs to an element. I gotta write that down. Like this A belongs to B. This. Wait, this is a difference. Let's make sure. Hold on. A subset. Yeah, this just means this is just another way of saying subset. I get these like symbols confused all the time. Unbelievable. We use the notation A as a subset of B to indicate A is a subset of the set B. If instead we want to stress that B is a subset of A, we use the equivalent notion B is a subset of A. So A is a subset of B and B is a subset of A are all equivalent statements, and I just confused myself. Check how the live stream's doing on YouTube. Because usually something always screws up when okay, there's my ugly face. That's good. Because usually something always screws up when okay, the audio is working fine. Sorry, Alex, or sorry if you guys have to experience that. And I'm gonna do another live stream tomorrow if for another studying stream. Another studying stream tomorrow, studying for this class and my other classes as well. Instead. 20 minutes. I'm gonna throw this away in the trash. Yeah, it's a receipt. I'll throw this away in the trash. I'll be right back. Alright, we're getting back. Why don't I see how long it's been? Oh, 26 minutes. Really? 'Cause I started this live stream a little bit beforehand, and I think it started like 3:01. 3:01. So it's been like what, 3 minutes, 1 hour, 1 hour 34 minutes, I believe, give or take. I'm sorry if this live stream is a bit boring compared to my other live streams. That's because I decided to like dedicate this one so it's more studying, more educational usage for more educational use than just goofing off live streaming, playing Five Nights at Freddy's or Minecraft or GTA or whatever. Sorry, I'm not totally close the line.
This video is a nice short introduction to functions. As any introduction video for my courses, a lot of this is just terminology, so that as we continue to study functions, when I use words like range or codomain or domain, that you understand what I'm talking about. So
Going on my phone. Oh, my phone. Probably shouldn't do that. Definitely shouldn't do that because I get distracted. And y'all know I get really distracted easily. So corn pop. See what OBS is saying about my viewers. 14 views, really? That's. See what's the YouTube creators. Sorry. 14 views, really? I'm getting 14 views? Nah, that can't be right. That can't be right. I don't believe it. Oh, I mean, if I have 14 views, that's wonderful. I love that.
Let's take a look at what we know about functions. A function f from set a to b, and notice how we denote that function, assigns each element of a to exactly one element of b. So every element of a, every element of a must be mapped to
Hold on.
must be mapped to some element of b. This would be considered a function. You might also hear of a function being called a mapping or a transformation, but mostly we just call them functions. And obviously it's important for us to know some of the terminology that we might see. So if we're talking about the image, let's say we know that f of 1 equals b. And I know that because that is this line right here. 1 maps to b. So if the input is 1, the output is b. So then I can say that b is the image of 1 under f, which would of course be that 1 is the pre-image of b under f. But be careful, because notice 3 also maps to b, so I would have to say 1 and 3, or the set of 1 and 3, more specifically 1, 3. We can also say, if we're dealing with the entire function instead of just one value or element of the set, I could say that the set of A, B, C is the image of f, the function f. Whoops. Also, let's talk about the range. Again, this is the domain. A is the domain, the set of all x's. B is the codomain, the set of all possible y's. And notice it's not necessary for each element of the codomain to be mapped to from an element of the domain. So the range is the set of all images, so the outputs, that are mapped to from the first set. So in this case, the range would be those values A, B, and C, because these are all values that were mapped to from the domain of A. From the domain of A. We might see functions represented in different ways throughout our study. One is as an explicit statement. An explicit statement just means that we are going to be told exactly which elements map to exactly which other elements in the codomain. And so this would be an explicit statement telling me that A maps to 1, B maps to 2, and C maps to 1. So that would be an explicit statement because there's no formula, or C maps to 1, B maps to 2, and C maps to 1. So that would be an explicit statement because there's no formula or function. It's just, here's what maps to this. In a formula, obviously, we're just going to have a normal formula. F of x equals x squared plus 1.
Okay.
We might also have a computer program. More on that as we continue to study discrete mathematics. Or you might have a relation. So we talked briefly about relations, and we will get into them in much more detail later in this course. But if I have a relation, and remember this is telling me that I've got some ordered pairs, 1, 2, 2, two, 3, 4, 5, 1, 7, 2, 6, etc. We could have a function if we only have one ordered pair for every element of A, which means this subset could be considered a function because I have not reused the x value of my ordered pair. Notice I did not include these two, which did reuse the 1 and the 2 from before. Here are a few questions for us to try just to make sure that we understand all of the terminology involved with functions. So first, let's answer what is the domain of the function that maps x to y, and the domain is the set x. We can see x represents a, b, c, d. The codomain would be set y, which is all of the values in that codomain. The range would be only the values of 1 and 2. So the set of values containing 1 and 2. The pre-image of 2 says what value mapped to 2, and then we can see here that that would be D. And the images of A, which would be what does A map to, so the image or images of A, and that maps to 1. And f of D means what does D map to, and D maps to 2. Now that we are familiar, maps to 2.
Okay. Let me look back at my textbook. I'm still on. "14 views." Is that really correct? Like 14 views? Sorry about that. All right. Hold on, I'm checking my live stream to see if it's we've been live for like almost 2 hours. Hold on, I'm checking my live stream to see if it's we've been live for like almost 2 hours. Whew. I have another monitor here that's attached to my laptop, so I'm just looking over here. Functions are sometimes called mappings or transformations. Functions are specified in many ways. Sometimes we explicitly state the assignments, as in figure 1. Often we give a formula, such as f of x equals x plus 1 to define a function. Other times we use a computer program to specify a function. A function f is a is b. A turns into functions from A to B. Okay, that's what it means. It means from A to B can be defined in terms of a relation from A to B. Recall from section 2.1 that a relation from A to B is just a subset of A times B. Relation from A to B that contains one and only one ordered pair A and B for every element A is a subset of A. Defines a function function f from A to B. The function is defined by the assignment f of A equals B, where A, B is the unique ordered pair and the relation has A as its first element. Alright, so stop touching my arm. I'll stop at 2 hours. When this says 2 hours, I'm gonna stop the live stream and take a break. Or maybe we can keep going. Yes, we can keep going. Let's continue. Oh, this live going on. Open studio again. Sorry if this live stream is really boring today. I'm sorry about that. Well, we're studying, so it's gonna be hella boring. But yeah. about that. Let's see where we are. Okay, so we're gonna stop here. It's been it's been like we're gonna have to stop the stream here. I want to go. Thank you guys so much for watching. So thank you so much. If there are any people watching, according to YouTube Studio, this live stream has received 16 views. I don't know if that's 100% true, but I'm taking that for granted. But yeah, if there are any people watching, thank you guys so much for your support. I appreciate it. Before I end the live, I'll take you back to my YouTube channel. Make sure to like and subscribe. Make sure to like the live stream and subscribe to my YouTube channel so we can have more videos like this. Make sure to follow me on Twitch so we can also have more live streams on there. Yes, it. And make sure to follow me on my Twitch channel, Phoenix_HunterYT, so we have more live streams in the future. And make sure to subscribe to my YouTube channel. Anyways, as always, stay safe and stay aware. Bye bye.